All right, we're in AP Calculus BC. We're doing self-check 1.3 today. So we need to graph this. How are we going to do this? Let's make a t, an x, which is t squared plus t, and a y, which is 2t minus 1. So for this parametric equation, I guess I can make my lines slightly nicer. Again, just kind of choose a value. I'm going to choose 0 for my first t and see what happens. If I choose 0, 0 plus 0 is 0. 0 minus 1 is negative 1. So 0, negative 1. 0, negative 1. There's my first point. I can zoom in here just a tad more. Let's choose 1. If I choose 1, 1 squared plus 1 is 2. 2 times 1 is 1. 2 minus 1 is 1. So 2 comma 1. Let's choose 2. Let's just keep going. If I do 2, 2 squared is 4 plus 2 is 6. And then 2 times 2 is 4, minus 1 is 3. So 6 comma 3. And it looks like I'm always moving 2 in the y direction, which makes sense because I have a slope of 2, which means my next point is going to be somewhere at 5, somewhere up here. And is there any pattern that's happening? 2 and then 4. Let's see, if I just choose 3, it'll be pretty clear. 3 squared is 9, plus 3 is 12, and another 2 gives us 5, so 12 comma 5, 12 comma 5. And I'm wondering, can I get any negative values? Let's see what happens when I do negative 1. Negative 1 squared is 1, and then 1 plus negative 1 is 0, so we get another x-coordinate of 0. And for over here, when I plug in negative 1, negative 2 minus 1 is negative 3, so 0, negative 3. Ooh, I can kind of guess what's going to happen. I'm going to guess it's some sort of parabola shape. Let's try negative 2. Negative 2 is going to be 4. 4 minus 2 is 2. Okay, so they're going to start repeating again. 0, 2, 0, 2. I'm going to get 6 and 12 for my next ones if I do negative 3 and negative 4. Or sorry, negative 3 and negative 4 exactly. And then if I do negative 2 over here, negative 2 times 2 is negative 4. Minus 1 is negative 5. So 2 comma negative 5, 2 comma negative 5. And you can see now that there's this cool axis of symmetry that happens right over this line. So I'm going to go, you always go up 1, up 2, up 2, up 2. So down 2, and then kind of reflect over. So if it was 6, it's going to be 6. If it was 12, it's going to be 12. And there is my sideways parabola. Go ahead and sketch a line that goes through those points. That's a parabola. And I don't know where it comes out over here. I'm just going to kind of estimate that goes like that. It does have to go beyond this this negative x, or this y-axis, to go into the negative x. We could actually test it out. If we plug in, how would I get a y value of 2? In order to get a y value of 2, I would have to plug in something that would make this, so negative 0.5. If I did a t value of negative 0.5, then I could get exactly what the x value is. Let's do, whoa, the number 2 got cut off. I'll have to fix that. This should be problem number 2. Find the values that make r is equal to 0. So again, you're looking for some number of radians. And then if I draw the line, so hopefully as I get closer and closer and closer to 0, I'll approach actually pi over 2 in this case. So the first answer is pi over 2. I get closer and closer to this line, pi over 2, and that will eventually get me to my pole of 0. So pi over 2 is the first one. And what about from this side? Getting closer and closer to 0 when I approach 3 pi over 2. So the answer are theta should equal pi over 2 and 3 pi over 2. No questions? All right, number 3. Find values of theta that make r is equal to 0. So we need to obviously make this top equal to 0. So I'm going to start with my numerator this time. Numerator. So I'm going to say numerator needs to be equal to 0. Therefore, sine of theta is equal to 0. And what I'm really asking here is, where do I have a y value that's equal to 0? So on a unit circle, you can think of this as my unit circle. Well, I guess it's actually right here. That's a bad circle. On my unit circle, where do I have a y value of 0? That means I have a y value here and here. That's going to be 0 and pi. So if I come back here, this happens at theta is equal to 0 and pi. Okay, over here, let's set the denominator equal to 0 to find all the bad values. So I'm going to set cosine of theta plus 1 is equal to 0, and therefore cosine of theta is equal to -1. So where do I have, this is really asking, where do I have an x value that's equal to -1? X value equal to -1 on this unit circle. X -1 only happens at this one spot on the x-axis of -1, and that happens at pi. So the bad values happened at theta is equal to pi, and I'll label that as that's bad. That's my bad value. Because if I have theta equal to pi, that means this denominator is 0 and I can never divide by 0. So I come back over here to my original problem and I say, hey, cross off that pi. My answer is just theta is equal to 0. All right, and then number 4, finally dealing with infinities. So whenever I have any number, it doesn't matter what this number is, but some number minus infinity that is negative infinity. And again, any number, even if that number is really big like this number, it doesn't matter what that number is, any number divided by infinity is always 0. And then finally, this one is a little bit tricky. So it doesn't matter what that number is, it could be whatever, but because I have a negative power, I now need to flip this to flip it to the top, and it now becomes negative 34 times infinity to the positive 2. So a negative times an infinity is a negative infinity, and infinity squared is still infinity, so the answer here is negative infinity. All right, so how are we going to score ourselves? And I'm just making this up on the fly. We'll say if you got at least one table value, give yourself +1 to at least attempt the table. And if you got the sketch correct, give yourself +1. I don't know what about the sketch, but if the sketch looks correct to you, it has some sort of axis of symmetry, you got the rough sketch correct, give yourself 1. So we'll say that one's out of 2 points. This one, if you got the 2 coordinates, give yourself 1 point. So that one's going to be +1 if you got both of those. It'll be out of 1. For number 3, if you found 0 and pi, give yourself +1. And then if you crossed off pi, give yourself +1. You can't just say 0, and that would be like a guess. So that one's out of 2.
Mr. Sindel, if we did the denominator first, and then on the numerator we did the right pi because we already knew it was wrong.
Oh, that's fine, yeah.
Okay.
As long as you somehow check the denominator and then get 0, I guess is what I'm saying.
Okay.
Yeah. And then infinity, let's just do a point apiece. +1, +1, +1, so that one's out of 3. How much does that add up to? 3, 4, 5, 6, 7, 8. That's going to be out of 8 points. Not an AP question at all. That's just the basics. How many points out of 8 did you get? Hold up your fingers. Whoa, nice.
Wait, how much was the second one out of?
The second one was out of 1 point. You either got both of them or you didn't.
And then 1.
You get 1 point if you at least attempted and correctly got one table value, and you get 1 point if you get the graph correct. Four? All right, nice. Cool, and then we'll probably get even better on the next time. So give yourself another 10 minutes, and then we'll do self-check 1.4. All right, so number 1, we need to convert to a parametric equation. These are pretty easy. If you remember your formulas are x is equal to, take whatever this r is, and then multiply it by cosine.
It's frozen.
Oh, oops. Unfreeze. Cosine of theta. And then y is equal to that same r times sine of theta. Having those memorized makes it nice and easy. So therefore x is going to be 2 plus, that's a tangent of 3 theta. All of this thing times cosine of theta. And then y, we can do it underneath here, or I can actually move the y over. I have technology. Underneath of this, y is going to be equal to this 2 plus tangent of 3 theta. I'll just copy and paste you, and that's going to be multiplied by sine of theta. Done. Give yourself 1 point if you got it. So +1 if you got both of them. Questions? All right, number 2. We need to convert to a parametric equation and describe its shape. So this, convert into Cartesian. I was like, wait, it already is in parametric. Okay, so from this one, I have a cosine and a sine, so I'm going to use the trig identity. The trig identity that we have to have memorized is that sine squared of theta plus cosine squared of theta is equal to 1. So knowing that, I'm trying to get a sine squared, which I have there. I just need to divide both sides by 9. I need to get a cosine squared there. So I'm going to deal with the y first. So if I divide both sides by 3, oh yes, the timer's up. If I say y divided by 3 is equal to cosine of t, then if I square both sides, so square that side and square that side, I have cosine squared. For this guy, I just need to divide by 9, so x divided by 9 is equal to sine squared of t. And then from there, I just need to plug this into our formula. So this is now not sine squared, this is x over 9 plus, and then cosine squared is y squared over 9, and that's equal to 1. And we have to describe that shape, and there's not a good shape. Oh, okay, so it's going to be a square root shape. So I'm going to have to isolate y, and there's not really a good way of explaining the square root shape. I think maybe next year I can make it so it is a nicer shape. I can maybe make that a squared. I'll give myself a note to do that next year. That way it's if it was this shape, what would it be? If that was a square instead?
Is it a circle?
It is a circle, yeah. If I change this, if both of these are the same number, then it's a circle. But if I change this 9 to like a 7, then it becomes a an ellipse. And if I change this plus sign into a minus sign, it turns into a, yeah, that one, hyperbola. But for now, this is the function that I have. So if I wanted to solve this, I would get something that looks like, multiply everything by 9, and I get y squared is equal to 9. This would be plus x. And then subtract the x from both sides, so the x is now over here, minus x. And then square root this, you get y is equal to 9 minus x, the square root of that, and that's some sort of square root function. The square root function that goes out like that. Number 3. Given the graph below, what values will make r is equal to 0? So again, kind of the same type of question. If I move along this curve, what line do I approach to make the 0? And it's this line right here, pi over 4. So
how do you know it's pi over 4 and not pi over 5?
Every single one of these is pi over 12, 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 pi over 12.
So it's never going to have a 5 unless it's in the numerator?
You'll never have a denominator of 5 in AP Calculus. And I try to make it the same way for all my other classes too, because it's such a weird number. What is pi over 5? That would be, I'll calculate it later. Let's stay focused on this. This is pi over 4 right here. So one of them is pi over 4. We'll list them all out. I'm going to do them like this. Pi over 4. And then the next one. So this one also gets closer to pi over 4. So it's the same value there. And then you can kind of see that it's the divided by 4s. So this one, they both get closer to this line right here. And that line is 3 pi over 4. So 3 pi over 4, and then the next one is going to be something divided by 4, and the next one is going to be something divided by 4. This one right here, you have to memorize, that's 5 pi over 4, 5 pi over 4, 5 pi over 4, and this one over here is 7 pi over 4, 7 pi over 4. If you ever get confused on if this is 7 pi over 4 or not, just count by 12. So like, how many 12s do I have? Well, I have 1, 2, 3 12s, or 3 pi over 12s, and that reduces to pi over 4. And then, if I'm going backwards, I had, right here, this is, I have 2 12s, so I have 28 pi over 12 here, and I go backwards 3. So if I go backwards 3, I'm subtracting 3, and that's going to be 25 pi over 12. Is that right?
Why do you have 28?
It should be 24. I don't know what I'm saying. 24 pi over 12. You just double 12 and you get 24. And then I go backwards 3, 1, 2, 3, and that's going to be 21, 21, pi over 12, which reduces to 7 pi over 4 if I divide the top and bottom by 3. Every one of these pi slices is pi over 12. All right, so I think it's just 1 point if you can get those, plus 1 if you got those.
What were the points on the last one?
Oh, I didn't do that, did I? 1 point if you were able to get cosine squared and sine squared by themselves, so isolating those. So there and there. And then 1 point if you somehow describe a square root shape. But this is a bad problem, I'll fix it next year, so that's a squared, because it eventually should be a circle. So 1 point if you said square root shape. Plus 1. So that one was out of 2 points. And then number 4, we need to do the same thing, numerator and denominator again. Numerator has to be equal to 0. So that's going to be cosine squared of theta is equal to 0. That's our 5-minute warning. Take the square root of both sides and I get cosine of theta is equal to plus or minus 0, which is 0. And then where is cosine is equal to 0? That's asking us where is x equal to 0. So on a unit circle, x equals 0 means I'm not moving left or right. And that's at pi over 2 and 3 pi over 2. So I'll write down theta here is equal to pi over 2 and 3 pi over 2. The denominator, set that equal to 0. Set that equal to 0, and we get sine of theta plus 1 is equal to 0. Subtract 1 on both sides. Sine of theta is equal to negative 1. Where do I have sine is equal to negative 1? That's where's my y-coordinate is negative 1. My y-coordinate is negative 1 only down here, and that's at 3 pi over 2. So that happens at theta is equal to 3 pi over 2. And again, the denominator set equal to 0. Those are our bad values. And that means I come back over here and I cross off 3 pi over 2. The answer is just theta is equal to pi over 2. Final answer box it. We'll give 1 point if you found numerators, 1 point if you crossed off or somehow found bad denominators. So I guess 1 point if you found the answer pi over 2, 1 point by crossing off 3 pi over 2 or something like that. That's going to be out of 2 points. So that's up 1, 2, 3, 4, 5, 6. This is out of 6 points. How many points out of 6 did you get? All right. What were the main takeaways from this self-check, girls?
The formula number 2, I totally forgot that.
Okay. The trig identity.
Yeah, and then I didn't know so much about the unit circle with the 12s, and I guess that the denominator was 5 a whole bunch of times, and it wasn't 5. So.
Okay.
Yeah.
Good takeaways. Tough one.
Well, for number 2, I was on the right track, but then I
Did you isolate the cosine squared and sine squared?
yeah, I got the y over 3 squared, and then I got the x over 9, and then I erased it.
Oh. Darn.
And then I got 3 right, but I just forgot what 5 pi over 4 was, and then number 4.
Okay. Cool. Thank you.